Today we're going to talk about dilutions. What is a dilution? It is possible to make lower concentrated molarity solutions from a concentrated solution by diluting it, which means we're just adding water. This is called a dilution. Solutions are purchased in standard concentrations of higher molarity, and then they're diluted because it's less expensive to buy a concentrated solution and make many others from it. So a solution that we buy in a higher concentration is what we call a stock solution. And that is one that is kept in stock, and then we make other concentrations from it. So when you dilute a solution, you use the law of conservation of mass to perform the calculation because the moles of solute always remain the same. So as you can see in the beaker on the left, we have 1, 2, 3, 4, 5, 6 particles of solute. And then on the right, we still have 1, 2, 3, 4, 5, 6. The solute is the same. We just added water. So here's the dilution formula. You'll see it as MC times VC equals MD times VD, or M1 times V1 equals M2 times V2. So MC means the molarity of the concentrated solution, and then VC is the volume of the concentrated solution. Sorry, typo there. And then MD is the molarity of the dilute solution, and VD is the volume of the dilute solution. And whenever you see the phrase stock solution, remember that will be the concentrated solution. So you can see, like I said, the formula is MCVC times MDVD, or is M1V1 equals M2V2. The important thing is that you know like which volume goes with which molarity when you're reading the problem. So volume diluted versus water added. So it's important to remember that the volume of the diluted solution is the concentrated volume plus the water. So you need to be aware of some phrasing. So when you see the phrase diluted to, that means you added water to a particular mark or volume, and that will be VD. That will be the diluted solution. So like on the beaker on the left, if I say I added water to the 50 milliliter mark, that means VD is 50 milliliters. However, because I started with 30 milliliters, if I see the phrase, I added 20 milliliters of water, that's how much water was added. It is important to note that this is not the volume of the dilute solution. In order to find the volume of the dilute solution, you would need to add that amount of water to VC to find VD. So over here, the volume of my concentrated solution is 30 milliliters. Now remember, because of sig figs, because this scale goes up by tens, I have to put a bar over that 0 to mark it significant, and then it's my estimated digit. And then on the right side, the volume of my dilute solution is 50 milliliters. So if I had a volume of 30 milliliters and I added 20 milliliters of water, I would need to add these together to find the volume of the dilute solution. So it's important to remember that. So here's an example. Say you need to prepare 150 milliliters of a 0.75 molarity solution from a 2.0 molarity stock solution. Your first step is to calculate the volume of the stock solution that is required. So I need to make this. So I need to dilute it. And I know that because my molarity is 0.75 and my stock solution is 2.0. So if the molarity is less or lower, that means that is the dilute solution. So this is the molarity of the dilute solution. This is the volume of the dilute solution. And remember, anytime I see the phrase stock solution, that will be the molarity or the volume of my concentrated solution. So remember, the molarity of the concentrated solution times the volume of the concentrated solution equals the molarity of the dilute solution times the volume of the dilute solution. So the molarity of my concentrated solution is 2.0. Its volume is my unknown. The molarity of my dilute solution is 0.75. And the volume is 150 milliliters or 0.0 milliliters. Now, when you're doing this, it's important to remember that your units need to match. So volume could be in milliliters or liters. It could even be in gallons. It really doesn't matter as long as the units match. So I need to divide both sides by 2.0 molarity. And then I need to multiply 0.75 times 150 and divide it by 2. And the volume needed to start with of my stock solution will be 56 milliliters when I do my division. So the next part of this question, so you can see number 1 is just what we did before, and we found that to be 56 milliliters. The next question says, how much water was added to the solution? So you need to remember that we had a beaker and we have the volume of my concentrated solution is 56 milliliters. That's what we figured out in the other problem. Now here it tells me I need 150 milliliters. So this right here is the volume of my dilute solution. So remember, actually, I'm going to write this in a different place. So remember, the volume of my dilute solution is the concentrated volume plus the water added. And I know that that is 150 milliliters. So in order to find my amount of water, so remember the volume of the concentrated solution plus the water equals the volume of the dilute solution. So that means that the amount of water is equal to the dilute solution volume, subtract the volume of the concentrated solution from that. So my water added is going to be 150.0 milliliters minus 56 milliliters. And I round to the ones place because that is my least accurate place, and that is the sig fig rule for that. So I get that 94 milliliters of water was added, which that makes sense because this right here is my water added. And if I add the 94 and the 56, I would get the 150. So that is how you would do a dilution problem and how you would find the water added afterwards.